Today, we aim to learn more about the current issues regarding minerals and the mining industry, including frozen projects and qualifications for corporations.
We also aim to explain how the mining industry operates, as well as clarify some processes used in testing minerals.
We went to the Mine and Geosciences Bureau in order to speak with experts in the field. Roll VTR!
Good afternoon po. I would just like to ask, we saw this po on your website about how you identify minerals through microchemical and megascopic testing. So we would just like to ask how it works.
Okay, the Megascopic and Microchemical Testing Laboratory is in one of the rooms at the Petrolab building, and I am one of the two geologists who is assigned there. What happens is when we have a visitor who wants to have the rock or mineral sample identified, we subject it to some very basic tests. For instance, let's say somebody submits to us a mineral sample like one of these. So what we do is we take a look at the basic physical properties that that sample has. In the case of a mineral, those properties that can be seen, that can be determined with very basic tests. This is the lab where we receive visitors who wish to have their sample, their rocks, and mineral samples identified and processed, or for whatever purpose they need. So when the visitor presents their rock here, we do a basic identification, which is, as you can see here, the megascopic analysis. These are the basic physical properties. So let's choose a sample and let's go through these one by one. No? Here, number one, the color, which is the most obvious thing we can say about that, no? About the sample. Now, the streak for minerals, for soft minerals, is the color of the powdered mineral when we scratch it on a streak plate. So we can do it with a streak plate like what we have here. And assuming that it is soft enough to be scratched, we note the color left behind. And then the luster, yung kintab niya, whether it is shiny, what kind of shine. Is it shiny like a diamond, like a glass? There are different terms for that. Hardness, yun nga, restricted to being scratched. So we have this scale from 1 to 10, softest to hardest, and then we use common household items that have a known hardest, like yung fingernail is about 2, 2.5. Ang ordinary knife is about 5, and then glass is about 6. So we can use those to get the hardness, di ba? Cleavage, for those minerals that show cleavage. Then fracture, when pag binibiyak namin yung bato. And then, of course, magnetism na self-explanatory. We use a magnet, syempre, for separating magnetic minerals. The most famous of which is magnetite, di ba? Parting, kung pwedeng mabiyak siya along planes of weakness, then tenacity, if it can be, if we can bend it, if we can break it, if we can crush it, and then we take a look at the shapes or the form that it has. For instance, you'll notice this specimen of pyrite forms cubic crystals, while these very large crystals of tourmaline, they form prismatic crystals, as you can see over here. That is the megascopic identification of a rock or mineral. The microchemical testing part of our lab is when we do a spot test for metals that may exist in that sample. So we take specific chemicals, we try to see if we can get a powdered form or a clean, fresh surface of the sample, and then we take a small portion of the sample and then we drop it into a test tube or into a dish with these chemicals to see the reaction. So the kind of color that forms with that reaction lets us know the kind of metallic ions that are in it. For instance, for potassium, for calcium, for magnesium. Although it might not tell us the quantity of those metals, it will tell us the presence of those metals. That's it.